About 6 months ago, a new LLM model hit the scene called Gorilla. I was eagerly waiting for something like it to be released. When it was released, I was surprised it took as long as it did too. I thought it would be an immediate game changer and would revolutionize the way that LLM models are able to interact with APIs. As it turns out, the problem of getting an LLM model to utilize tools and execute its own functions is a more difficult problem than what initially meets the eye. In order to get AI to utilize tools, you essentially need to invent the wheel for AI. Then, you need to reinvent the wheel a series of times until the model has access to every single tool you want it to use. Just as the first intrepid inventor who created the wheel likely met with a group of disinterested faces, so too do you have to take the extra step of also explaining to the AI how the tools work and why it should use them. Once you have cleared all of those hurdles, you are still faced with the biggest one of them all. Attempting to train LLM models to utilize tools in the ways we want them to use them goes against the very nature of what it is to be an LLM model. An LLM model is, in its very nature, a predictive beast. If an LLM were to describe the world to you, they would describe it as probabilities and statistics. What is the exact chemical composition of rain? This is not a question an LLM model is built upfront to answer. What is the percent likelihood of rain tomorrow? This is a question that is far more up an LLM model's alley. There is no probability built into a function call. You either structure the call the right way, and you call the right endpoint, or you don't. The function call does not give you 90% credit just because you only transposed the final digit in the post address. It returns a 404 error in those instances 100% of the time. Training an LLM model to utilize tools is akin to training a police dog in a lot of ways. A dog is not naturally the go-to for such rigid, structured, and disciplined work. With the proper training though, and given the correct breeds of dog, police dogs can be just as impactful to a force as police humans. The key aspect here though is proper training. If you want to end up with an LLM model that can use tools, you have to give it a lot of training, both on what the tools are and how to use the tools. If you construct the curriculum well, and your base model has what it takes and soaks up the learning opportunities offered, you end up in the end with an LLM model that is equipped to handle tools and functions. How does it do these things in the end? The same exact way you do. It builds and executes function calls. All of the training you provide to the model in these areas is everything it needs in order to build and execute the function calls it creates. GPT-4 possesses an advantage on this front that most other models do not have. This training process is intensive in and of itself. The ability to use tools requires a great deal of mental processing power. If you train a standard LLM model to utilize tools, you essentially end up with an LLM model that is capable of utilizing tools, but not so great at other tasks. GPT-4 has enough mental processing power to get around that equation. For us mere mortals, this has presented a bottleneck of sorts. Use the tool functions provided by the OpenAI API, or take your ball and go home. For a year now, this has been the landscape when it comes to agents. I have seen a plethora of agent frameworks released during that time. I stopped reviewing them because they all had the same flaw. They all rely on the OpenAI API. What good is building multiple roads to the same house when it already has multiple roads leading to it? Today, researchers from the Harbin Institute of Technology in China have made my AI agent dreams come true. They have released the spiritual successor to Gorilla, not one, but 2 LLM models that are specifically trained to be tool-using agents. At its core, KwaiAgents is 2 LLM models, a 7B and 1 3B model. Combined with the system of tools and benchmarks offered, you have the full KwaiAgents architecture, unless you are one of the handful of people in the world that have fine-tuned a Gorilla model and have it within your stack. This is your first opportunity to create truly local agents that is released. The authors also did it right, simultaneously releasing the model paper, the GitHub repository, and the model itself on Hugging Face. You can find descriptions to all 3 in the description of this video.
Imagine you have a big toy box with many different kinds of toys, like cars, dolls, blocks, puzzles, etc. You can play with any toy you want, and you can also make new toys by combining different parts. This is like having a large language model, LLM, that can do many different things with words, like writing stories, answering questions, making jokes, etc. Now, suppose you want to play a special game with your toys, like building a castle, or pretending to be a doctor, or solving a mystery. For this game, you need to use some specific toys and follow some rules. You also need to remember what you did before, and plan what you will do next. This is like having an agent task that requires a LLM to understand queries, follow guidelines, reference documents, update memory, plan actions, and provide responses. To play the game well, you need to fine-tune your toy box. This means you need to rearrange your toys, so that the ones you need for the game are easy to find and use. You also need to learn the rules of the game, and practice how to play it. This is like fine-tuning a LLM for an agent task. You need to adjust the parameters of the LLM, so that it can use the knowledge and skills it already has for the specific task. You also need to train the LLM on some data that is related to the task, and test how well it performs. Fine-tuning your toy box makes it easier and faster for you to play the game. You don't have to waste time looking for the right toys, or figuring out how to use them. You can also play the game better, and have more fun. Fine-tuning a LLM for an agent task makes it more accurate and efficient for the task. It doesn't have to rely on general knowledge or skills, or guess what to do. It can also provide better results, and satisfy the users.